All right, I think the clock has struck 2, and we're going to start on time, and hopefully finish on time. So, good afternoon. I hope everyone's recovered from this wave of announcements this morning. So I've got nothing this exciting to announce, as you've all heard this morning about all the cool stuff we've been doing for the Universal Windows platform, making sure your apps can run everywhere in all sorts of different flavors and devices. Today I'm going to be talking about Microsoft Edge, which was previously known as Project Spartan, and what we've been doing in the tooling space there, and how you can, hopefully, my goal for the talk is for you guys to walk away with a few things that you'll see, hopefully, that are new in the tool. So next time you're fixing a bug in a website, for your be it for the internet or wherever, hopefully you can go like, aha, there's this little feature hidden somewhere in F12 that can make my life a teeny bit easier. So I'm going to show you a lot of cool stuff today, hopefully. So firstly, I guess a public service announcement. All the sessions are obviously evaluated. I will put up the QR code at the end of the session. Please scan it, give feedback. Feedback's great. Obviously helps me make the talk better next time round. So please provide feedback. So firstly, and the most important thing, if you only get this one thing out of this entire talk today, I've done an okay job, is that we have the developer tools. We've got a brand new browser. I think you've seen some demos of the cool stuff it can do with like inking and stuff, and some of the talk about extensibility for it. But we realized that as part of a new browser, a key part of that is the developer tools. After all, it's got a brand new engine, the Edge engine, highly interoperable engine, lots of features like new HTML5 and whatnot features. And so clearly tooling, to take advantage of those features, to use the latest ES6 stuff, or whatever particular feature in the browser you're looking at, we need to have some great tooling. And so we're committed, obviously, to making sure that the tools for Microsoft Edge, I've got to keep saying that, not Project Spartan, are the best tools that we have on our platform. So OK, so now I've done my talk. Most important things conveyed. Everyone goes back to the pool, has a pina colada. Or you can stay and listen for a bit more and see some demos. So one important thing, I think, is really a turning point for us with the tools. So if many of you used the tools before IE11, who's used the developer tools in Internet Explorer before IE11? Quite a few people. You'd remember how painful they were, like going back to hilarious things like you have to refresh the DOM whenever it updates and stuff like that. They were really built for a different generation of browsers, like specifically the IE6 generation of browsers. The world's moved on a lot. And in IE11, we got to turn this amazingly big ship that was the tools around and redo a lot of the tools that we had. So you saw a new debugger, a new DOM Explorer that didn't splatter you with empty text node everywhere and updated as the page updated. But we didn't quite finish taking what we had in IE9 and IE10 and before even, and revamping it for this new modern world. So with Microsoft Edge, much like how the platform has now you've got your Internet Explorer, which you can use in your enterprise applications. It supports ActiveX and everything that you have known and loved about IE for the longest time. And you also have Microsoft Edge, which is almost a new beginning for the browser. It's an interoperable engine, fast, performant, and with the latest features. So we're doing the same thing in the tools. We're essentially taking the tools and going forward, like after Windows 10, what you'll see is that the tools are getting better in Microsoft Edge. And then at the same time, the ones that we have in IE11 on Windows 10 are going to stay the same. They're not going to sync. It's perhaps a bad analogy, but they're going to be frozen. Like, hopefully they're not going to sync. They're not going to get any worse. They're just not going to be touched, and they're not going anywhere. So the ship's going to be cut off power and adrift. Hopefully it won't hit a rock on the way. But we're not focusing on those tools. The tools that you have in IE11 on Windows 10 are the tools you'll always have for as long as that browser is supported. All our new features are going to be in the Edge, Microsoft Edge browser. So when we add new features that support either latest standards or even some features that support existing standards, it's going to happen in Microsoft Edge. So for modern web development, the tools in Edge will be your best bet. So that's something worth keeping in mind as you switch between, perhaps you'll be transitioning an app from IE11 and moving it forward. So the next thing, just a bit of context before I go into demos. I intend to spend most of this talk doing demos, because I like living on the spot. But I've got 2 more slides to hopefully set some context. So if you cast your minds back a long time ago, perhaps the mid-2000s, developer tools like Firebug were really just coming into existence. And people were moving away from using essentially alert. Like everyone, I imagine a lot of you today still use window.alert to log code. Yeah, fair to say? So, but that was the only way of doing it in the past. Times have moved on, and browser tools have got ever more sophisticated. Things like the old IE Dev toolbar that worked in IE6 to Firebug, and of course the Chrome developer tools. The expanse and the richness in those tools has ballooned. They've become from simple tools that you could log messages, like use console.log and stuff like that, set breakpoints, inspect styles, to very complicated suites of tools that have a ton of features. They allow you to profile your application, HTML, CSS, everything, the whole shebang. They allow you to take memory snapshots that walk the entire DOM and provide you an accurate representation of your running application. So they've gone from these small, relatively simple tools to this huge suite of tools. There's no better way to put it. And, it's very competitive if you look at even like fully blown debuggers like Visual Studio. In fact, in the JavaScript space, the F12 tools have more features than they have in the JavaScript for debugging experience in Visual Studio. Things like trace points, event breakpoints, XHR breakpoints, all sorts of other features that simply don't, and source maps as well for non-TypeScript, don't exist in the Visual Studio JavaScript debugger, but they do in the F12 debugger. Because ultimately, all the browsers have been investing in their tools, and every browser you look at has got this ever-expanding, ever-richer set of APIs, set of features. So as a developer, there's this ever-burgeoning expectation of what you get from your tools. Like, it's not like people are paying for debuggers. They're not even paying for high-end profiling tools that might have been true a while ago. So when we think about tools and when we think about what we do in F12, we have this in mind that, hey, there's this huge set of almost, for lack of a better term, interoperable or expected features that cover everything from some examples up here, and that's obviously not exhausted. They're pretty much shared by all of the browsers. And many of those features represent the 80%. Most of the time, I think it's to say you're probably looking at tracing styles or debugging JavaScript. You're probably not spending 80% of your time in the memory tool, unless you're very specifically tasked with looking for leaks, and which I feel is very sorry for you. It's not always a fun task. But there's also places where each of the vendors differentiate and are a bit unique. So when we do features, we think about it this way. There's this common set that is basically this ever-expanding set of tooling features that people expect in their browsers, and it's important for us to deliver. But there's also a place where there's unique features that are only in some browsers. So Chrome does a fantastic job of device emulation. We can throttle the network, change the screen size, all that sort of stuff. Firefox has had like this 3D view for some time, has shader editors and whatnot. So they're also having some unique features. On our side, the unique features that we think about are often around two, I guess, real key problems. One is trying to find good ways for you to identify your problem. And the second one is trying to find ways for you to get your code out of your developer tool, out of the browser tool, and into your editor. Since ultimately, I'm sure many of you have done this, you've selected an element, it's mispositioned, you tweak the style a bit, and you have to copy and paste it back into your editor, right? You have to go back to Visual Studio, Sublime, Brackets, whatever editor you're using to make the change more permanent. And so things like, if you've seen in the past, we did track changes. Has everyone seen track changes here? Hardly anyone. OK. 2 people. Awesome. So I'll also demo that feature for free. It's not new in Spartan, but it's been around for some time and is really handy. So we've also, and that tries to help you get your changes out of the browser. The other thing we want to do is make it easier for you to find your problems. So one of the features we added in IE11 in one of the updates was Just My Code. Has anyone tried the Just My Code stuff in the developer tools? OK, a few people. So if you're not familiar with it, the basic idea is that your website is composed of tons of different libraries and frameworks and things like that. But debugging jQuery isn't going to help you. There's probably very few problems that you've encountered on your website that are caused by a bug in jQuery. They obviously happen, but you're not likely, and even if it is in jQuery, you're not likely to be fixing the bug in jQuery. So you want to work around those issues. You don't want to be stepping and step into jQuery, be confused, keep pressing step, and then step right through your own code. So things like Just My Code make sure we only step in things that are your code and not library code. And you can tell us what is library code by marking the file. So let's go on to some demos. So firstly, a big caveat, there's going to be dragons, lots of scary dragons. Hopefully not Welsh dragons, just general dragons. If anyone recognizes the theme of the dragon, it's Welsh. And so I'm going to be doing a whole set of demos on Microsoft Edge. Let me just switch to my demo machine. 5. All right. So the first thing I'm actually be demoing isn't something in the tools themselves, but it's something about the tools. Have many of you worked on an enterprise application or any application that's embedded IE? So you've got a WinForms or a WPF application, and it's embedded inside another application. You've got some HTML, JavaScript, either locally or on a server. And anyone? A few people, not many. So it's a pretty common scenario, especially in enterprises. So one of the things that can be a challenge is it can be a bit of a pain to debug those things. Obviously, if you've got a Visual Studio project that's a WPF app, and it hosts the web browser control, you can debug the C# brilliantly, but you can't really touch the JavaScript that easily and touch the DOM and the console, your CSS. So what we've done is made it so that F12, via what we call F12 Chooser, can attach to anything that's running IE on your machine. So if it's in a .NET app, if it's in an old school Win32 app, even if it's a WWA and things like that. So I've got this awesome app, which is my version of a browser. It's highly competitive. It's got resizing, and it's got a nav bar, and you can click stuff. But what I'm using this for, it's obviously a Windows Form app, and if you could use this thing called F12 Chooser, which will conveniently find in Windows System 32. So you can also search for it, but if you're looking for it, it's in Windows System 32, which is the folder that everyone knows and loves. Over in F12, there's a separate folder, you'll see this little exe. And so launching this, what it's going to do is it's going to enumerate all the instances of IE, like regardless of where they're embedded, if they're in a WinForms app, a web app, or whatever, and show you them. So you can connect to them from here. And this works for Spartan. And the first tip of the day is that for this release of Spartan, Microsoft Edge, that you can see I got used to it already, the best bet for debugging is actually going to be use F12 Chooser, just because right now it's a wee bit more stable than the... That's a bit creepy. The live video is running. Let me just kill that, because we don't want to watch that. There we go. OK. So here you can see I've got my demo page open. I just connected to it from F12 Chooser by selecting it from the list. And then we're going to kill this. There we go. And so one of the first tools that we've been working on that was a difference from IE11 is from when we had IE11, there was two tools that we hadn't really touched. One of them was the network tool, and the other one was the script profiler. So the network tool in IE11 was essentially the same one it has always been since IE9, IE10, just that we changed the colors and made it more white and removed some 3D effects. But now we've got a brand new tool. So if you go to, in fact, let me go to open a new page. And this new tool is written in HTML and JavaScript. It's worth mentioning that all our tools run as HTML and JavaScript applications. So the tools we build are built in TypeScript, so we compile down to JavaScript, which is really handy because as developers, it gives us a lot of insight into debugging JavaScript. The tool will also eventually be in Visual Studio. So if some of you have built, has anyone built like the HTML and JavaScript applications for Visual Studio? Oh, sorry, for Windows? No, very few people. If you did build those, you'll see the same tools in there. And eventually, hopefully, the network tool, as it's generally applicable to the network stack, like HTTP traffic, HTTP sys traffic, will also be available for XAML apps. As you can see, we're having some fun navigating. So let's just go to the page that's already running with a one thing downloaded. No. This always happens to me. Sorry. So it's just being a bit responsive. So the network tool, as Microsoft Edge catches up, what we've got here is so firstly, most of this tool is in that category of tooling that I think most of you will be familiar with, which is that, hey, that's like, my expectation is that you have a network tool, it captures data, it has visualizers, it has like timings and stuff like that, and that's exactly what this tool is. So you can see here that eventually what we'll have is a list of, here we go. Please work now. What we'll have is let me just start it again. Sorry about this. What we have is two different views. So we have a summary view, which is a grid. So if you're familiar with many tools, they have a similar pattern where they have an overview of all the network traffic. And then we have a way to inspect each individual item in that traffic. And so you can look at, obviously, the details. You can look at all of the information, the response and the request bodies and headers. And funnily enough, in this particular build, you can also debug F12, which you can see is what all these tools down here are for. OK. But one of the nicest things about the network tool that's different is that it's always on by default. So if you go to a page, it will be started as soon as you launch F12. So before, if you use the F12 tools, you might have had to go to the network tool. Classic scenario is you've spotted a network issue, like some sort of download trouble like that. You go to the network tool, it's not there, because you weren't recording. So you turn on recording, and then you rerun your scenario. So now the tools are always on, which is awesome, because it saves you an extra step. All right. There we go. Woohoo! So you can see, pretty much as you'd expect, a new modern UI. Like one of the things we've tried to do is improve upon the UI quite a bit, so it's easier to get to your information. You'll spend less time navigating around the tools themselves. On the right-hand side, you can see we tried to show all the detailed information. So the left-hand side is obviously the summary view. It also contains a pretty graph along here, which is the timings. And the detail, for each of the types of network data, like be it the headers or the body themselves, we've got some visualizers. So obviously here you can see like the headers. You can also see specifically cookies. So if you're familiar with cookies, they obviously come across as one big long string. And they all have like, it's URL encoded. Here we break them out into different things. And so you can easily see them. And in the future, we're also looking at adding a cookie inspector to the debugger itself, to the tools themselves, so you can modify these cookies. This is just a read-only view. This is just showing you the network traffic. It's not allowing you to tamper it. Have timings. So all of this stuff should be familiar to you. It's a basic network tool that you've come to expect from pretty much every browser, right? There's a couple of nice things that we do. Like we have some great visualizers. So if I filter it down to documents, so this is a new thing that we didn't have in the old tools, you can see that we're using the same visualizers as we use in the debugger. That also means you can pretty print. So you can pretty print HTML, JavaScript, CSS, and you can even pretty print JSON. So it's a thing we get asked about a lot. Oh, here we go, it came back. Is pretty printing. So it makes it much easier to see the network traffic. So for example, if we're interacting with a JSON REST API, and it's sending back minified data, you can just pretty print it, and it will look something like this. But since it's JSON, it won't be CSS and HTML, hopefully. So we've got all the same features from the previous version. So things like clear cookies, always refresh from server, which is a really handy feature because basically what refresh from server does is passing along all the way through the network stack, like, hey, get me new data. So if you've ever had this annoying frustration bug where you made a fix, you deployed your fix, but the browser is still seeing the previous version of your fix because for whatever reason, the cache information hasn't changed, like the E tag hasn't changed and it's still being valid, then turn on this button, which is on by default, so just don't turn it off, and you'll get the latest information. One of the things that we've done to the tool that's new is we've added a support for the HAR format. So anyone here familiar with HTML archive format? It's a way of saving network traffic. So one of the nice things about this is a way of persisting all the data that's captured in the network tool and saving it to disk. So that's useful because you can attach it to bugs, you can attach it to emails or other things. There's also other tools built around this format. So for example, if I go save this file to, let's say my disk and call it foo, I can then open up another Microsoft Edge instance and find an example. And people in the community have built viewers. So they either run things like YSlow against it or like a simple HAR visualizer. So in this case, if we open it up as a text file, because this app just takes raw text, but it's a JSON format, so let me show you it. So this is what a HAR file looks like. It's just JSON, very simple JSON, and it encaptures all that recording traffic. So if you had a network bug, you could attach it to your repo and stuff like that. And you can also load these back up in F12 itself with the open, unsurprisingly. But you can also use tools like this. And what you can see here is this is just another visualizer of that same data. And so some people, and you can Google it later, I'll bring it, have got like plugins for YSlow, if anyone's familiar with YSlow and stuff like that, that will basically perform operations on the data. They'll look at it for like common patterns, like, oh, hey, you made 10 network requests to the same domain, or you've not minified your CSS, etc. So another handy feature that was added to the network tool. Another also kind of useful thing that we've had for some time is a download initiator. Has anyone used the download initiator stuff or know roughly what it is? So one of the key, not many, no one can raise their hands. So one of the key problems about the network is trying to figure out where your data comes from. So like say in this case, we've got this page which has a broken image, and we're trying to figure out, well, where did that come from? What we can do is we can go to the right version of F12, since I got so many of them open. That one. Oh, no, that's the network tool. So the downside of calling something network HTML, and at the same time, our network tool is ingeniously called network HTML. And so what you can see is that if this is the right thing, which I don't think it is, you can see that, like, here we got a 404 error. It's probably a bit discrete, but there's color-coded. And what happens in the initiator column, if you scroll to the right, is that it says where it comes from, a past element. And so if I go load up my demo properly, let's just close this down. Close this down. It will tell you like this line information. So in this case, what I've got is an image, like I said, that's been an image source tag, but the source tag is wrong. And it's pointing to the, it's mistyped. So now when I refresh the page without turning on the always recording, what you'll see is that there's a bunch of extra information in the, let's just minimize this view by clicking this, in this initiator column here that tells you where it's downloaded. So if I go to this 404, so if ever you find a website and you've got a 404 or 500 or something like that, you can click the link and you can find out where it's being requested. And that took me back to the debugger, which is pointing, as you can see from this little arrow here. This little arrow is a new thing we added, is a bit of a help. Shows you it's coming from here and where it's Microsoft.log rather than logo. So a very simple thing that exists in the tools to help you get from your network traffic information, which is like a read-only view of the data that's coming down, to your source code, where you hopefully can make your change, and fix the issue and redeploy it. The other thing in the network tool, let me see what else we got. Save as high, yeah. Is that we've been working as well on the parsed element stuff. Oh, no, skip that. There's a bunch of ways to get it out, copy and paste, things like that. If we just go to the JSON thing 1 minute, I'll hopefully be able to show you pretty printing JSON. So again, pretty printing exists in F12 for HTML, JavaScript, CSS, JSON, and everything like that. Really simple to use. It's this cryptic icon in the, and that's another feature, by the way. If you have F12 today, you can do Control+ and Control- to zoom in and stuff. So if you ever found something's too little, too big, you can do this today just like you would do browser. You can just use Control+ and minus, which is a bit easier sometimes than using magnifier. So this cryptic button over here, pretty print and word wrap. So useful features if you need to try to find some data. Another thing that's really handy for finding data is we have search, and the search is across all the contents. So search will look in headers, it will look in bodies, it does highlight matching. So if you type in like query string, you can, oops, if I learn to type, you can see it's got it highlighted here, and you can obviously go next. But the other thing that's often overlooked is the matches are also on the little highlight bars here, these little blue notches in the scroll bar, so you can jump around and find the stuff pretty easy. So that's useful. Not all the tools have that as an ability to search all your contents, which makes it much easier to find stuff, obviously. So the next set of demos, we're actually going to do the debugger. So one of the things, let me just skip to the, there's 2 sets of demos for the debugger we'll look at. One is really that core set of features that a lot of people come to expect, and then the other stuff is some innovative things we're adding. So the first one is a simple feature called XHR breakpoints. So I think everyone's probably seen the breakpoints window, but is probably wondering what the hell are all these cryptic icons in the top right. So there's tooltips, that makes it accessible, right? This one is a new one we added. This is XHR breakpoints, which I'll just demo, and just add one. This is the trace points for events. So if ever you've been using code and you've got like a click handler or something like that, and you want to log something for it, you can just add a trace point rather than adding like a console.log by modifying your code and redeploying it. That one's event breakpoints, if you want to break on a click and stuff like that. We're not going to demo in this, but since you've probably not seen it, there's a bunch of events you can break on. There's also conditions which you can apply. And they'll let NAS2 just enable and delete all. So anyway, we've added an XHR breakpoint, which is this one here. And surprisingly enough, what that's going to do is going to break in the code that's handling your XHR request. So you might have used this in other tools, where if you ever want to just break in the response, essentially the ready state change for, this is how you do it. The nice thing here that's different is there's async call stacks. Has anyone seen the async call stacks feature and used it much? No. Is everyone familiar with like the general async call stack stuff? Probably not. Okay, so I have a switch back to the presentation, and I'll show you a bit of a walkthrough of what this means. Okay, so one of the problems we try to help you with in the debugger, and we've added a lot more instrumentation in Microsoft Edge, is that you probably write a lot of asynchronous code. Like you probably have like XHR, timers, or event listeners. And so the problem is that something that you might think, oh, that looks like a synchronous code block. Like this is a really simple example of using XHR. Is actually a set of very disparate operations that is either waiting for user input or waiting for interaction from an external provider. And so what we try to do in the debugger is not just show you the call stack of your current point of execution and all the calls that led to that, but we want to also show you all the logical calls. So we want to show you where your click handler was wired up, where your XHR was sent and stuff like that, to help you solve problems like perhaps your XHR is wrong because the URL was wrong. It might be the case, and it probably is the case, that right in the code that's handling the response, you're not constructing the URL. So you can't obviously look at that. And in fact, finding that in your application might take a bit of time to figure out. So we try to show this all linked together. And so to go over this in an awesome PowerPoint animation system, you can imagine that this is your application. This is the entire extent of my awesome application. We start here, because it's global code, and we're going to have our first async operation already. We're going to call add event listener. And so add event listener is going to depend, obviously, on DOM content loaded to happen. So nothing else is going to execute right now until DOM content loaded happens. And so this is the first point that we've added some new instrumentation in Microsoft Edge, where we'll basically log how should we say, we'll record this fact. We'll take the call stack, which in this case is just global code and init, and put it in a stash somewhere. And then sometime later, the browser will come back and say, hey, DOM content loaded has happened. Do the next set of stuff that you need to do. So in this case, what I'm doing is I'm taking my button, since that's now been in the tree, and I'm wiring up a click handler. Again, nothing's going to happen with this button just yet, and we're going to log a like, hey, an async operation has been started again. This add event listener has been wired up, and this was the stack. So the stack now is obviously global code and the DOM content loaded event fired, which shouldn't be on. Yeah, anyway. So now we skip ahead, and the user clicks the button. And this obviously happens at any point in your application. And so we're creating an XHR request. So perhaps this button's going to go fetch some data, executes these things synchronously, and then, again, we've wired up another event listener. This time it's on ready state change. It could have been add event listener, ready state change. They're both synonyms of the same thing in the browser, and they get wired up the same. Again, we take the stack. So in this case, it's the on-click handler coming in from global, since everything always comes from global. And at some point later, we now send the request, and at some point later, we're going to actually break in the debugger. So with an XHR breakpoint, this is the point where we break in the actual response. But already there's been 3 or 4 steps that have led up to this happening. And so those steps can be very important when it comes to debugging, since you, for example, might be thinking like, oh, I need to go back and see whether the XHR object was constructed to make sure the URL was constructed with the right parameters and whatnot. And so that's exactly what you see here, is that entire trace. And so we do this for other things, not just XHR and add event listener, but obviously timers. So wherever you're building an application that's using async events, which is probably everywhere, because it's a JavaScript application, so obviously event-driven, you should be able to see these logical stacks. And this is what I mean by async call stacks, is the ability to see these things that happened in the past. And it could have been a long time ago, hopefully not too long ago, but it certainly didn't happen with the same execution stream. So that's a handy feature, and so in Microsoft Edge, we've extended that to add more instrumentation. So now buttons and the DOM is basically fire add event listener all wired up. So you should much more easily be able to trace back through your application to find out what happened. All right. So the next of stuff we've done for the debugger is really about improving the source navigation. So do many people use TypeScript in the room? Okay, a few people CoffeeScript? No one, okay. Any other compiled languages? You're probably all familiar with the idea that, hey, that JavaScript is an awesome language, great for a lot of things. One thing it's obviously not good is typed. It has, it's not strongly typed language, you don't need to rehash that. But the downside of that is it can be very hard to create clear objects, have clear contracts between different components and things. So many people choose to use a language like TypeScript that allows you to have rich, strong typing and a compiler that checks for simple mistakes. So if you fat-fingered something like I did all the time, it allows you to check for those sort of things. Now, that's great on the compiling and editing side, but I'm talking about the debugging side now. And in the debugger, all we've done in the past is really just show you source maps. So this is a little ray tracy thing. And if I go to, you can see in the file picker, I've got my TS file with an awesome logo. And of course, I get all the syntax classification. And if I set breakpoints, they're all expressed in terms of TypeScript. But we haven't taken advantage of some of the things that we get from a strongly typed language. And so some of the biggest ones we get right now, or have added, is the ability to do go-to-definition. So here, if you use the context menu, you'll see 2 things. One is the go-to-definition, find references. So go-to-definition, it's kind of silly, takes you to where the object was defined. So in the case, I just went from a type, a vector, and so I've gone to the constructor. But it also means that if I go from something like, let me find this div here, and if I go to definition, it'll jump me to where it is. So in that case, that was just 2 things apart. But what it takes means you've got this application, it's got lots of objects, lots of classes, you've done the right thing, you've got a strongly typed language, you've used a strongly typed language, you've outputted your source maps and your compile code, and you can now in the debugger use the go-to-definition and find references to navigate. So when you're stuck at a breakpoint and you're trying to figure out where was this object defined, where was it created, right-click go-to-definition. But the reverse thing is also very handy, and that's find references. So if you go to find references, let's find a better example in a second, what that will bring up is this little window at the bottom of F12, which shows you all the places in which an object is referenced. So anywhere where someone set that value or used that value, so here, let's take on a bigger thing, and you can easily navigate through your application to find out where it's used. So that, if you've got a TypeScript application like this one, there's only a few hundred lines of code, but if you have a much larger application, that's really useful, as it allows you to essentially do some of the things you're used to if you use Visual Studio, like jump around and navigate your source code without a lot of effort. So a pretty handy feature. And again, it's trying to take some of the things that have existed for strongly typed languages and in richer editors and try to bring them into the in-browser tool experience so that when you're debugging your TypeScript, you have a much better time. This also works for JavaScript, but find references and go-to-definition for JavaScript is a bit flaky since it's not strongly typed. And so your results will vary depending upon your application. If your application is just evaling one big string, it's going to be very hard for it to work since it's working not at the execution level, but it looks at your source code. So if your source code is one big string and an eval, you're going to be out of luck. But then you're having so many problems that you're probably out of luck anyway. So yeah, so the next set of things that are kind of new for the tool, we can quickly do the console. So one of the useful things about the console is we did something very simple, which is wire it up to the escape key. So if you press escape, so to be consistent with other browsers. Again, like one thing we don't want to do is be different from other browsers and things like keyboard shortcuts for no good reason. So in places like, for example, you can use escape key to open the console. You can also use the same shortcuts you can in like Chrome for continue. So obviously in F12, F5 is continue, but F8 also works. So we try to keep it so the shortcuts are the same. So when you go between your different browsers and between your different browser tools, you might not have to relearn as many shortcuts, which is kind of handy. But one of the biggest things we added was better instrumentation to help you get to your code. So again, this is one of those common features across browsers, is I've got this simple code that if I just open it up, it's going to be the world's simplest application. You can see we've just got a simple log statement. Obviously goes down here. And now we have the source location log. So this is a feature we were missing for a long time, was the ability to just say like where the message came from. So as you're using your application and you're logging to the console and stuff, you can now just have a simple like link that will take you back to the place where the log came from. Really straightforward. The next thing we also added was not just logging, not just source locations for JavaScript, but if you're using a source map, hold on one second, it also works for that. So in this case, I've also got a TypeScript file that's making use of console.log, and you can see here, just about, that it also comes from the TS file, and you click it, and it'll take you to the TS file version of it. It's .ts, which has obviously a class and stuff like that. So trying to pervasively use source maps across all the tools. So realizing that one of the things as a developer that can really help you is using these rich languages that do static compilation and stuff like that, and trying to bring some of that handiness back into the tools that you use for debugging. All right, so on a similar vein, one of the things we also did was to add it to the DOM Explorer. So for a long time, we've had it in the debugger source maps, so for TypeScript, CoffeeScript, whatever, but we've not always had that for the DOM. So in the DOM, if we just inspect an element by going to the DOM Explorer, I've got this button in the middle of my app that looks just fantastic. But the interesting thing about this button isn't that it looks amazing, it's that it used Sass. So you click on this, and rather than seeing the CSS file, what you see is the Sass file. So we've got, so you have support for source maps. So if you're using source maps like Less or Sass or Stylus or whatever you're using to generate your CSS, that's now in the DOM Explorer. And there's these visualizers, like you can see, that colorize it for each language. Another nice thing is that stuff I mentioned before for find references, go to definition, also works here. So I've got these buttons and this color here, and you can do find references. And if I zoom out a wee bit, what it will show you is that just at the bottom, it's listed all the places that those variables have been used. So if you're not familiar with Less or Sass, one of the things it allows you to do is define variables for things like colors or anything, really. And then you can reuse them in your application. So rather than having to look for FFF in your application and changing it manually to some slightly off-white color that you might be using, you can declare a variable. The nice thing that allows us to do in the tools is to link those things together. So you can do things like you can find references, but also if you're on a much bigger style sheet, you can just do like go to definition, and you can jump back and see where it's defined in the code. So you can navigate around not just TypeScript and other execution like JavaScript languages, but also around CSS, so Sass and Less specifically. So it's a great way if you're using some of these more advanced compile options to make better use of them in the developer tools, rather than having to manually search and find and stuff, which is, of course, the fallback. Yeah, and the other thing, if I turned off source maps for this one to show another demo of something, which is this button here, we also added printing for CSS. So now, pretty much everywhere in F12, you should be able to pretty print stuff. So if it's minified HTML or even minified CSS and JavaScript in HTML, it should all pretty print. Let's press the button. There we go. Pretty straightforward. So that's handy, of course, as you come to use these compile languages, because sometimes you'll probably be minifying stuff that isn't from a source map language. So the last, or the real big change that we made in the tools was, like I mentioned, was for the old script profiler. So we talked about how we changed the network tool, but the last one we did, we also changed the, stop generating, and let's close this. We also combined the JavaScript script profiler into the UI responsiveness tool. So we used to have two tools. We used to have the UI responsiveness tool, which was awesomely named, and we also had the script profiler tool. So one of them would profile your HTML, your CSS, and stuff like that, but it wouldn't profile script execution. So if you saw script execution, you'd see this big bar in the graph that just said like script execution. But you wouldn't be able to see what really happened. You'd be able to see the event that triggered it, you'd have to use a script profiler to profile your JavaScript. So what we did is we've moved both the tools into the same thing. So here you can see that on this tab here, there's also your JavaScript call stacks, which is pretty useful. So it's all in one place now. So like if you want to see anything in your application, you want to do any profiling, you just use the performance tool, and you get both the JavaScript call stacks and, of course, the timeline like you did before, so HTML, CSS, and stuff like that. One thing that's also been added that is useful to show is that we added a feature. One of the problems of tools, like if you're profiling tools have a couple of problems. One is they have lots of data. They have an awful lot of data, and it's very hard to think, like, what the earth actually is this data? Like, between these 2 points in time, what happened? Because ultimately, you're probably profiling a scenario like writing an email, playing a game, or something user-driven. And of course, the profiler doesn't really understand user-driven concepts. It understands what the platform understands. So what we did is there's two standard, really, APIs, performance.mark and performance.measure, that you can use to instrument your code. So if you've not seen these before already, they're in all the modern browsers. And their basic idea is you instrument your code, and you create this array of timings. So what you can see here is that you say, like, performance.mark, the start of your scenario. So say in this case, we're going to do stuff, but it could be anything. And it could be not just in the same stack, but it could happen minutes later. It doesn't matter. You just say mark, start of scenario, and then at some point later, when that scenario is ended, you go example scenario end. So that gives you 2 points in time. But you probably want to measure the time between those two things. And to do that, that's where performance.measure comes in. And in that, you just pass in a name of it, the name of the scenario you're going to call it, and the start and end measures. So you can reuse measures this way and have multiple measures that use the same mark sort of thing. And so that's great. And the purpose of this API is you can then log that to your server. You take all the data in performance.measure and you send it back via JXHR to your server, and you can see how well your application's doing. And that's fantastic. But we also, in the tools, have changed it so that that will also appear here. So you can see that in the tools, you'll start to have a user measure section. And what you can do is you can filter to just this event, and it will show you what's happening just at that time. So here you can see that there's a DOM click, which is an event, and this is all the things that happen just for that particular scenario. So you can filter out all the data that was surplus for this particular profile and focus in just what you want, which is useful, especially if you have a scenario that has tons and tons of data, and you're just looking for a specific set of sequence of events. And again, that also focuses the JavaScript call stack, so you can see only the things that are happening in the JavaScript world that were relevant at that particular time. The other nice thing that we've done to the tools is we've had some integration with the DOM. You can see here that as I click over things that happen on the DOM, we highlight over in the page. So if you ever see a HTML element or a node in the perf tools, we'll be able to highlight it if it still exists on the page, and also have a Show in DOM Explorer button, which will take you back to the individual thing. So you can go from your perf tool, where you're tracing and you've got this information, and you can go back to the DOM Explorer. Because a lot of the time, you might want to go tweak something over in the DOM side or just see where that element was. And so some better integration between the two different tools to get backwards and forwards. But the useful thing to remember is that when you do profiling, do try to instrument your code, because that really helps the profiler tailor the information and you to scope it down, so you're not looking at thousands of reams of events, but more just the ones for your particular set. The other big change in the profiler was we moved away from being an instrumented profiler. So for this, I'm going to step back to IE11 for a second. So in IE11, one of the things we had was we've had this profiler. It's what you call an instrumented profiler. So the way it works is pretty simple. Every single time you enter a function, every time you exit a function, we record something. And we have this huge log of stuff, which we aggregate and stuff and present you your data. It's great in terms of it tells you exactly what happened to the individual call count on individual functions. The downside is it has a huge overhead. So like if you take this is just a regular page, and this is IE11. Let's press it a few times and see what data we get. So ignoring the first one, because the first one's always slow because of the jet. And now if we turn on the open up F12, what we'll see is the perf goes down drastically. Okay, so let's try that again. Because one of the things we do in F12 is we turn on debugging. So when you open up F12, we tell the engine, hey, you're in debug mode now. That obviously impacts perf, because we're telling the engine to keep around some extra information, do some extra things that it wouldn't normally do. So to get around this, if you turn on the profiler, we turn that back off. But as you can see, the downside here is the way that this application works is the instrumentation, which is what this profiler here does, is actually much more impacting than even just being enabled for debugging. So you can see the last result I did, which is when you were recording profile data. Okay, thank you, magnifier. I didn't even know you could break. Oh, crap. Yes, yes. Okay, so what you can see here is the last one with the profiling turned on was 2.6, which is almost double the time, well, it was over double the time it took with debugging enabled, and almost, what, four times slower than with just regular page. So the point here is that instrumentated profiling has a huge impact on the actual data you collect. So the downside of that is if you're profiling, and your profiling makes things slower, depending on your application type, it can lead you to all sorts of weird places where you should have never looked. Because especially things like hot loops, where you've got a small function that's been called a lot, like instrumented profiling is pretty bad, because it will just say like, oh, this is your problem, when actually what it means is the way I record this data is the problem. Sorry. So what we changed is over in IE for Microsoft Edge on Windows 10, we moved to use CPU sampling. So the way CPU sampling works, if you're not familiar, is that at a set interval, like every X milliseconds or every microsecond, what it does, it takes everything that's on the stack. So it literally takes the CPU, walks everything that's on the stack right now, logs that. So the idea here is that if things to be statistically relevant, they should be on the stack in this sampling interval. So the smaller functions, the small things that don't exist won't be so impacted because it's a lot less overhead. So now if I try the same thing, firstly I'm going to load up a page that doesn't have debugging enabled, because that's going to mess it up still. And let's just see if it runs at the same time. OK, about the same time. So now, let me turn on profiling and hope the numbers are roughly the same. They're obviously never going to be the same. And we turn on profiling and go. So 686, so it's about the same. So the point here is the profiling doesn't have an impact that it used to have on your application, which is really useful. The other thing to keep in mind while we're doing this is that if you are ever doing performance data, like you're tracing and you're outputting to the page like I am, or you're outputting to console.log, turn on the profiler anyway. Even if you're not using the profiler, if you turn it on, you'll see slightly different results, which will be more representative of what your customers are doing. Because again, F12 will turn on debugging, which hopefully your customers don't do, so that will obviously impact the trace. In the future, we'll be adding a little disconnect button so you can disconnect the tools from debugging, which will set the engine back into its normal mode, so you won't be impacted by this. So yeah, so that's the first really cool thing about the new profiler. So it's all in one. It's changed to be CPU sampled. We have user measures, so that was the ability for you to instrument your code to specify certain points in time. So the last tool to really quickly look at was the memory tool. So the memory tool is the sort of tool that you use when you have to use. Have any of you spent much time looking at memory leaks? Anyone? A few people. So as you know, they can be really painful. Memory leaks are often the sort of things that are caused by things like loose references or stuff like that, and they can take a lot of time to analyze. And the tools themselves, again, contain a lot of data. We literally take every single object you've got. So if you've got a complicated application, that's hundreds of thousands of objects, which is a ridiculous amount of data. And so what we tried to do, and we've improved in Microsoft Edge to make it more obvious, is the ability to take snapshots. So what I've got is I've got a button, and I've got some code that if I go to this code and look in the debugger, it's a really canonical example of a leak. It's a pretty simple leak that you probably wouldn't ever do. It's an orphan node. So in the memory tool, what we try to do is to highlight things that are potentially problems. And so in this case, the problem is that we've got a reference to a node, but it's removed from the DOM. So we've got an element, whatever that element is, we've removed it from the DOM so it can never be rendered, but we've still got a JavaScript reference to it. So it's essentially orphaned from markup. So hopefully you wouldn't have code that looks just like this, but what you do is we take a snapshot, we press the button to leak it first, we go back to the memory tool, which is running, take a snapshot, and what we should see is a little button. Did we not do that? Try that again. There should be a little highlight button that shows you curse it. In this left-hand side, I'm not sure why this demo isn't working, on the left-hand side there's a little exclamation mark that will show you when you've leaked a node. So if you ever see those, that's a good indicator for somebody to look. So if you use libraries, quite a lot of libraries have like document fragments they keep off the side, and you probably won't want to touch those. But if you do have your own code, and you can see it referenced in here, look for the little like information icon on the left-hand side. The other thing that's really handy in the tools that we do is, again, along the lines of, why are you not found error? Oh, I don't say I've got a problem in my own application. Typical document. OK, that's not debugging now. The other thing we do is we've got a console method to try to, where you can instrument your code to take a memory snapshot. So a classic scenario for your profiling memory is to try to get a diff, because you're looking between, for leaks specifically. You take a point in time, you take another point in time, you compare, and you see what's different. The problem is that in UI, like if you're just to use the F12 tools, you have to press a button. Like at the same time as you're running your application and doing whatever your scenario needs to do, you need to switch the tools, press a button to do that. So it's obviously not quite as high fidelity as you might like. So we've got this thing called console.takeHeap_snapshot. And so what you do in your code is, again, when your scenario starts, you take a snapshot. When your scenario ends, you take another snapshot. And then you can diff those. So if we go use this, and you go to the memory tool, and if we look at the summary view, because we won't see it in other places, what you'll see, oops, I pressed the button there, is you take snapshots and they appear in this list here. And so then you can go ahead and diff them. So the idea here is that you can instrument your code, and this is probably one of the most important tips in terms of profiling, is if you instrument your code, you're providing much better information into the tools that hopefully allow you to spend less time wandering around and trying to figure out what timestamp gets to what timestamp in your application and how to measure the end-to-end of the scenario. The other thing we've done in the tools, as soon as I open up one of the snapshots, is much like the performance tool, we've tried to integrate it with a DOM Explorer. So if I find a HTML div, of which I hope there's many in this application, you can see there's things like there's the highlighting again. So you can see very literally that this object in the object graph over in your memory is this object over in the DOM, which is pretty nifty. And again, just like the other things, you can right-click, show in DOM Explorer, and go back to the element in your inspection tool. So again, that's probably more in the common set. Like if you used other tools, you might have seen that. But it's really nice. It allows you to get from one place in your code, which is this object graph, back to your actual application. So you can see where the node is in your tree, rather than just looking at it from the object graph side of the house, which is fun and all. So then we go back. OK, so I think we've got a few minutes left. Yeah. So I think that pretty much covers the demos. Let me switch back to the slides. Yeah. So there's a few things that we haven't done yet, and we're hoping to do in future versions of the tools. And we're going to add, to do this, we're going to add an experimental set of features. So this will be a separate thing, like a separate tab. It might just look like something like that, let's say, where you can enable certain features. And the features we're looking at enabling is firstly JavaScript editing. So it's something we don't have yet in the tools. But funnily enough, the editor you saw in Visual Studio Code today is the same HTML and JavaScript-based editor that we use in F12. They're off the same common code base. So we want to enable JavaScript editing, so you can not just find and debug your issues, but hopefully fix them. So typos and small errors like that, you can easily fix. Same for CSS. So like today, obviously in the DOM Explorer, we have the ability to edit styles via the trace styles view. So you get this rich object graph, like a tree, and you can tweak stuff and stuff. But sometimes you just want to edit text. And that's really what the edit CSS feature is the ability to edit text. The last two things are really about inspecting state of your application. So today, if you use cookies, there's no real way apart from the network tool to see what's in your website. So what we've done with this experimental flag that you'll see in a future flight, don't know when exactly, but in a future flight, you'll see like a grid view where you can edit your cookies, you can change their values, delete them, clear them, all the sort of stuff you'd expect, all your basic CRUD operations. Same goes for local and session storage. Today, if you're having to cache data in a persisted form, like in local and session off the DOM, you can inspect them in the debugger in the console, but that's not the most convenient form. So what we've got is viewers for those, again, so you can edit them in a grid. And hopefully over time, what we'll be able to do is add more experimental features. So not only is Windows shipping faster, and consequently we're shipping faster, but you'll also have things that we're working on actively so that we can get feedback. Because the key thing that really helps us drive what we do is really getting feedback of what you guys need to be more effective and more productive in debugging your websites, especially with Microsoft Ed. On that point, the last real thing, I think before we go for 10 minutes of questions, is that we have a bunch of ways to give feedback. Like we really appreciate any feedback you have, either on bugs you see, features you'd like to see, or just problems you're having, even if you don't know what the solution is. We'd love to talk to you, because we want to obviously make sure that the tools we build are the best tools for you. Right now, the way to reach out to us is there's a user voice. So has anyone seen our user voice? Like a few people vote there. Like that goes whenever we do like product planning and stuff. We look at user voice, and that affects where it gets in the stack of things we do next and stuff like that. So obviously go there. For bugs, for now, you've still got connect.microsoft.com, which is where you file your bugs. We also have a bunch of stuff that isn't just for F12 on GitHub. Some of the other things that iTeam do are things like allowing you to connect the Chrome Dev Tools and other editors and stuff to IE. And of course, on Twitter at IE Dev Tools. So do reach out to us, and obviously, like, we've got some time for questions now, and then I'll be around in the booth, which is on the second floor, just by the cool 3D scanning thing. Has anyone seen that? No, 3D scanning and 3D printing. We're right next to there. If you want to look at a browser and not have your image scanned in and printed, which I don't know why, but do come talk to us. So yeah, and on that, we'll open it to questions and the session evaluation stuff. So okay, so first question. Yep, so the question was, you've got a brand new Win 10 machine, it has Microsoft Edge, it has a whole bunch of new stuff, like you're using Angular 2.0, which has like a built-in support for TypeScript essentially, because it's somewhat built on it. How would you set up? Well, the first thing is that for Windows 10, the VS 2015 RC was just announced, and so that's the version of Visual Studio. It has a set of Win 10 tools. For this version of the browser, Microsoft Edge, we don't target debugging from Visual Studio. So if you happen to be using Visual Studio to build an ASP.NET application and launch it, right now in like the preview, you won't be able to do that without some workarounds. And same goes, so you won't be able to like press F5 and launch Microsoft Edge. In a future version, you should be able to do that. So there's a bit of a road bump. Question at the front?
Yeah, you showed us the async call stacks with XHR requests.
Yep.
Is this for XHR requests only, or can we do this for set timeouts?
Yep, so the question was it the async stuff just for XHR? The answer is no, it's for anything that uses set timeout, set interval, or any of the timers, like request immediate animation frame. It's for anything that uses add event listener. By anything, I mean anything that's in the DOM. There's obviously some things that aren't there, like some ActiveX objects and stuff, but less of those. And then also, you can instrument your own code. So there is an API that I didn't show here called debug.msasync, and you can, if you have a library, you can instrument your own code to be, say, like, hey, I'm starting an asynchronous operation, start here. So if you're building Win.js, or you're building Ember or something like that, and you have a message loop that's going, but your customer is just using a promise, say, and they don't understand this message loop task thing, then you can instrument your library such that all they see is the promise chain. They don't see the task looping chain, which is probably set timeout or set interval that they're doing.
What's the name of the
It was debug.ms async start operation, end operation. In fact, if we just open it up, we can find it like in the console. It's currently like it's a Microsoft-only API. MS, you use these ones here. Trace async and, oh, sorry. Those ones. Yeah, there's MS-10 documentation how it explains how to use them. Any other questions?
Yeah, are they getting rid of the major release
Yeah, so the question was, are we going to get rid of the major releases like we've had like 9, 10, 11, and don't have 12? I don't know. Definitely not my space. I do know that for the tools, we plan to just do like incremental updates. Like in general, apart from like the big versions to support like the change to IE11 and Microsoft Edge, it's mostly like incremental at this point. So I can't say for Internet Explorer or Microsoft Edge what their version plan is. All I can say is that we plan to update more frequently by the Windows Insider program and stuff like that. Is it possible to get a dark theme with developer tools? Actually, the funniest thing is you can turn on high contrast mode dark. And then, no, the tools themselves aren't themable, but our own implementation is basically we have a list of tokens in CSS. It's just not exposed in a way that's configurable right now. The only way you can get a dark theme is high contrast dark, which is pretty extreme if you ever used high contrast modes in Windows. Any other questions? Yep, so the question was, with Edge coming to phone, what's the deal for debugging that? So you'll be able to use Visual Studio. So there aren't going to be the dev tools on the phone, obviously, and these tools won't currently plan to work remotely. So you'll be able to use Visual Studio like you can today with Mobile IE. So today in Visual Studio, since 2013, we've had the capability to debug Windows Phone, Internet Explorer. And so that will essentially be the same. It's not in the RC, so it's not in the bits that shipped, but it will be hopefully in RTM, where you'll be able to debug Edge on the phone. and get these same tools. Like I mentioned briefly, all these tools are actually in Visual Studio minus the debugger, which for obvious reasons is not in Visual Studio. Any other questions? All right, well, I think we finished 5 minutes early. Like I said, I'll be on the booth if anyone has any more in-depth questions later on. Thank you.